Hello, my name is Rebecca Wilson. I am the Marketing and Communications Manager at Copper Mountain Technologies. A couple notes about our webinar today before we get started. I will be recording and sending out the recording of the webinar after it's completed, so you'll be able to watch again if you have anything you missed or want to watch again. If you do have any questions throughout the webinar, we'll answer them at the end. You can submit them by either going to the Q&A window. You can find the tab next to the chat window. But if you want to stay in the chat window the whole time, there is a checkbox at the bottom underneath where you type your message that you can click, and it will be added to the Q&A area. So when we're done, we can go through the questions and the answers. I'll welcome you to our webinar on simplifying IoT antenna testing and accelerate your product development. We have Olivier, Robin, and Gregory Makar here from Pulse Antenna. And I'm going to go ahead and give it to Olivier and let him get started.
Thank you, Rebecca. Do you hear me?
Yes, we do.
Okay, very good. Hi, everybody. Olivier Robin speaking here on behalf of PulseLARSEN Antennas. So we're going to start the presentation. First, I'm going to speak for about 20 minutes on all the benefits that this kit will bring to you. And then Greg Makar will do a presentation, a live demo. You probably, hopefully see a video live feed on top of the screen. And on the left side, you're going to see the slides passing by. So I'm going to start now, and then Greg will continue with a 30 minutes plus live demo of the kit. So this IoTest kit is composed of a few things. And as I speak, Greg is opening the kit in front of the camera. You have a antenna analyzer P60 that is co-developed with Copper Mountain Technologies. This P60 is embedded in a black foam, and we will explain you why during the demo with Greg. There is also inside a calibration kit called the P911. It's a traditional RF short open through calibration kit for the one port of the antenna analyzer. There is on board an RF cable, some connectors, adapters, and also 18 demo boards that are containing antennas and that are ready to be measured. A demo board is more or less a test board, demo board, or reference design. It's basically a PCB connector, SMA connector, a antenna soldered on the PCB, and it's ready to be measured. So this is a short description of the kit, and you're going to see how it works in about 15-20 minutes from with Greg. So what are you going to be able to take away from that kit? So from that training. So basically, you're gonna understand very quickly that we have designed a kit that allows you to do a very fast 1-minute setup to be able to perform RF testing on a demo board that you will pick up from the 18s that are available in the box. And obviously, you will pick up the one that corresponds to the frequency that you want to work at today. So we have various frequency covered, and we'll cover that topic later on. Then once you are sure with that software that we co-developed with Copper Mountain Technologies, once you have measured the right plot compared to what is saved in a device, you will be able to connect that kit, that antenna analyzer, to your product and verify that the antenna impedance, the antenna return loss in your device of your antenna will be correctly measured or not. And therefore, you will be able to compare to an existing reference board and do an analysis if the antenna is well tuned or not. And the software will show you very quick if it's good, if it's bad, if it's great. And also, for those of you who are not familiar with a VNA or a reflectometer, the software tells you exactly at what time you need to calibrate the device to make sure that you get the right impedance of the antenna that you're measuring right now. So why is the antenna design important for your product? We get that question very often. So as you know, most of the customers today, a lot of customers today are buying antennas off the shelf from the main distribution channels, which is fine. So we call them off-the-shelf antennas. And each antenna comes out with a data sheet. Each data sheet is built upon certain conditions. So sometimes the conditions from the data sheets are not exactly the ones that you will have in your product. So it is always very important to verify the antenna design inside your product in the real case of the application that you are trying to develop, so that you know when the user or when the final user, the end user, is going to use the device, the antenna will be tuned for that specific application. In that case, this IoTest will help you to check if the antenna frequency is correct, if the bandwidth is correct, if the impedance of the antenna is correct. It will then show you a return loss plot, which is a negative number expressed in dB. And in the next slide, I will explain you, for those of you who are not familiar with return loss, what do you expect from that kit. The antenna will then typically only transmit a ratio of the accepted power it gets from the source. So that power, that accepted power, will be transmitted into the air based on, depending on the efficiency of the antenna. So sometimes if the antenna is not tuned correctly or for the right application, there is too much reflected power back to the radio, and therefore the amount of power accepted by the antenna is not optimal, and therefore you radiate less into the air. So some people would call it a weak budget link or weaker budget link. Some people would say there's a big mismatch between the antenna and the radio. At the end of the day, that IoTest kit will allow you to verify that the antenna tuning corresponds to what you expect in order to meet the spec or pass the FCC or the PTCRB testing. So I have 3 slides next to explain why is the antenna design important and what is a mismatch at the antenna level. So basically, you can imagine on the picture on the picture on the left side of the slide, you have a radio, you have a transmission line, and you have an antenna. This antenna, or this radio, sorry, is sending power at a certain impedance that we call Z0. The antenna impedance is Z. And what happens here is that if Z is exactly equal to Z0, all the power transmitted by the radio will be accepted by the antenna. Okay, it sounds very simple. So if the impedance of your antenna is the same as the output impedance of the radio, basically 50 ohms most of the time, then you have no power reflected back to the radio. That will create a minus infinite dB return loss, which we call a resonance. And that antenna is then able to transmit the power that's accepted into the air. So that's what you're really looking for. Now, it's very hard, very difficult for the antenna designer to match an antenna over the whole frequency band that the radio can offer. So it's an engineering work, and most of the time, except at the resonance frequency, most of the time the impedance is slightly different from Z0. Therefore, the reflected coefficient, the reflection coefficient is different than 0, and then the return loss gets a certain value in dB. So it could be -1, -2, -10, -0.5 dB. So if we go on the next slide, I'm trying to explain here that IoTest device will show you a plot. This plot is the gray plot that you see on the chart here. So in the y-axis, in the vertical axis, you see the return loss in dB. On the horizontal axis, you see the frequency in megahertz. And the plot, the gray plot, is the return loss of the antenna. So what you want to do, you want to make sure that there is a nice resonance in the frequency band that you are working on. For example, this antenna has been tuned for 2.4, about 2.44 meg, sorry, 2.44 gig. And the bandwidths, the markers 1 and 3 are located at 2.4 and 2.48. Those markers are at minus 8.2 dB and minus 8.23 dB return loss. So it is commonly accepted that a good antenna has a return loss below minus 10 dB. Minus 10 dB corresponds approximately to 10% of reflected power at the antenna port. So if the return loss is below minus 10 dB, 90% of the power transmitted by the radio will go through the antenna and be eventually radiated in the air. Okay, so now what happens on the edges there? So basically, if your return loss is very close to 0, that just means that the impedance is far away from the impedance, the output impedance of the radio, and that a lot of power is reflected back to the radio and not absorbed or accepted by the antenna, which means that the antenna is therefore not tuned or not matched, and no power will be transmitted into the air. So it's very simple. So in that case, the next slide is all about power. Some people understand power better. So we translated that mismatch issue into a power amount that's being transferred to the antenna and radiated into the air. So same picture on the left, you have a radio, and as an example, we set up an output power of 1 watt at 915 megahertz. We send that power into the antenna, and we have 2 cases below. One case is, case number 1 is, if the antenna impedance is 50 ohm, okay, case 1.1, at that frequency, you will have a very deep return loss at that frequency. You will have a very minimal amount of reflected power, which means that 1 watt will actually be accepted into the antenna. And if that antenna efficiency is 100%, which is seldom the case, but the antenna efficiency is set by the nature of the antenna and by the type of materials we use to build that antenna. But let's take a theoretical a number. If the antenna efficiency is 100%, it will therefore transmit in the air the full amount of accepted power, which is 1 watt in that case. Now, in the case number 2, if, for example, the measured antenna impedance is 25 ohms at 915 megahertz, you will then create a return loss of minus 9.54 dB, and that will correspond to 88% of the power to be accepted by the antenna, which means that if the antenna efficiency is actually 100%, so everything that comes in goes out, you will transmit in the air 0.88 watts, which that means that a 25 ohms, as opposed to the required 50 ohms for the maximum output power transmitted, will induce a 0.12 watts loss into the IoT device. Okay, so a bad tuning will imply a loss of power transmitted in the air. Of course, if the antenna efficiency is only 50%, you remove 3 dB of that power compared to the level above mentioned, and you get 0.5 watts or 0.44 watts. So antenna mismatch is very important during the design phase of your IoT device. And again, that IoTest can help you correct that mismatch if you have it with you all the time. So we as an antenna supplier, we care about antennas, obviously, but we tell the whole world that choosing an antenna is not an afterthought. The antenna design, most of the time, is better if it's considered from the beginning of the design of the product. Just because in that case, the antenna bandwidth and the antenna frequency, the antenna gain can be taken into account, and therefore we can modify the mechanics, we can modify the layout, we can modify the surroundings of the antenna to get the maximum budget, the best budget link or the maximum output power from the device from the beginning of the design. Antenna design is not black magic, as a lot of people want it to be. It's all about managing the electromagnetic fields. So the IoTest will help you to manage a part of the fields, a part of the parameters for that for your antenna tuning. If you want to have all parameters taken into account during the design, you will need the IoTest or the and an anechoic chamber, and in that case, you can cover the mismatch losses and you can cover any issues in the radiation pattern. Of course, as an antenna company, we have worldwide engineering support, worldwide chambers all over the world, and at different locations, and of course antenna analyzers all over to make sure we can help our customers. So we do believe that kit is very important for you, and I will now list a few examples where the P60 analyzer, the antenna analyzer, can be useful for your needs. So what is it that the P60 can do for you with a minimum amount of RF skill sets or minimum amount of knowledge about how to use a VNA or a reflectometer? The antenna tuning to the radio output impedance can be obviously done with the IoTest. That's the main goal. The main goal is you visualize very carefully, very easily, where is your antenna impedance, where is your return loss, and if it's not in band, if it's not having the right bandwidth, it will help you to correct that phenomenon. If somehow, so if the center frequency is wrong or shifted, if the bandwidth is not correct, in other words, if the antenna tuning is not optimal, then the IoTest will help you to get better. It can also help you to see if the antenna is radiating or not. You know, it's the best antenna in the world is a 50 ohm load. 50 ohm load gives you the best bandwidth, gives you the best return loss, but it's not radiating. So if you put a 50 ohm resistors at the end of the line, the transmission line, it will just absorb the power. It's called losses, will not radiate anything. So Gregory, during the demo, will show you how you can visualize somehow very quick if your antenna is radiating power outside in the air. This P60 antenna analyzer will also help you to see if the PCB that you are using is having the right shape. If not, you can modify the shape of your PCB using copper tape, for example, that you probably have in the lab, and therefore you can see if you can improve the bandwidth or improve the antenna gain. By gain, I mean antenna impedance, antenna matching, antenna sensitivity, and therefore, if it's more sensitive, the gain of your antenna is probably higher. It will also help you to debug if the antenna connection is good or not. Independently, if you use clips, pins, or wires, you will be able to see the change in impedance. It will also help you to identify the amount of impact generated by anything else that's around the antenna in your device. For example, acoustic components, speakers, microphones, earpieces. Usually those devices are fed by two lines, the plus and the minus, or signal and ground. Those lines sometimes are so long that they are just having the right length to generate a quarter wavelengths at some frequencies and just creating losses in your efficiency in your budget link. So the antenna will radiate the fields and it will couple to those lines, and therefore you will create some losses or you will see a big drop in efficiency. So that P60 will be able to show you a worst return loss if you're not choking the lines. So that's something you can do very easily with the P60. Of course, if you move around, if you have wires or display or FPCs or even other antennas battery connections, chokes, shield cans, cables crossing your design. By moving those elements around, you will see a direct impact on the return loss of the device. If somehow your antenna is detuned by body loading or by some resin, epoxy, by some putting materials or magnets, you will also be able to move them around to make sure that your antenna is detuned as little as possible. You will also be able to, once you move your antenna from one location to the other inside the device, you will see that very quickly with the IoTest. And if somehow you realize that you have some grounding issues and you see a band matching, by changing the grounding, you will see that live the return loss of the antenna will be modified in one way or the other, and you can see that very quick with the IoTest. On the next slide, I'm listing here some cases where it will be very practical to have the IoTest in your lab or at the place of work. So we hear a lot that as the antenna supplier, we hear a lot that next week we are going to mass production. Today is Wednesday. And we're going to get the new PCBs tomorrow, and we don't have time to tune the antenna, and we hope it's going to work. So again, it's very hard when you have a day or two left to call an antenna supplier and verify the tuning, making a report, doing an quick measurement report. If you have that kit, at least you can verify within a few minutes if your matching is good, so you feel good going to mass production, or you feel good before going to as the bullet number 2 mentions here, you feel good going to a third-party lab for the last testing iteration or for the certification time. When you go to a third-party lab and you have one time slot defined 6 months before for making sure that the antenna or your device is passing the spec, it is good in that case to have the IoTest with you. It's very mobile, very compact, to just do a quick sanity check before they run the testing, so that you avoid a lot of situations in which the third-party test lab tells you that next time slot available is in 6 months, and you have no choice. You need that certification to go. You might get priorities if you pay more, etc., etc. So always good to have the IoTest with you wherever you go before certification, just for sanity check. We also have a lot of customers that buy catalog antennas, off-the-shelf antennas from various distribution channels, and unfortunately, when they go into reality, they put the antenna in their device, and somehow the application of their particular business means that the device will be underground or very close to water or in potting material or in certain conditions along the human body, and that will detune the antenna. So it's always good again to have an IoTest with you so you can verify the tuning in the real conditions. We also have a lot of customers needing tracking for animals or big products like white goods or containers, again, who have difficulties to ship to the antenna suppliers prototypes, for example, because it's too big or not possible at all with live stocks. So it is good for you to have that kit so you can do your own test, run your own test in your lab or in the area where you work, so you can perform basic antenna sanity check and make sure your device is tuned. Some startup or universities also have a limited budget, and we believe that kit is very affordable. I'm going to talk about pricing at the end. And we also have companies that have very strict confidential projects running, and they do refuse, even though you have an NDA in place. They don't want to send prototypes. They don't want you to see the box. They don't want you to see the size of the box or whatever. So having the IoTest in the lab is good for them to run the first tests. And therefore, they can only require help from the antenna company if they really are blocked in a situation where they cannot get out. So this is why we conceived the IoTest. Again, we believe the IoTest is a very easy to use plug-and-play device for your antenna testing. It includes a lot of guidance in the software. You will see that in a few minutes. It's again very simple to use, plug and play. Within a minute, you get the results you want. It's ideal for people who are on the field or traveling extensively, and they need to be able to perform very fast engineering support for their customers. People who are always on the go, on the ladder, fixing antennas on top of a mast, verifying that before they get down the truck, the antenna is tuned. It's a very, very compact design to carry around. We also have 24/7 worldwide support. You can call the 800 antenna number, as I will show at the end of the presentation. So again, we believe that kit is very useful for field application engineers, technical sales on the road, design houses, home office workers, or system integrators that need to do a quick sanity check before they start designing or during the design process. If somehow your company have RF engineers that are starting their career, that tool allows them to bypass the complexity of a VNA understanding, and therefore goes right to the point and be able to measure antennas very fast. It's also a very good kit, we believe, to help you when you are really under strict timelines or financial timelines, in a way that you really need to perform your test in a third-party lab, and you get stuck there because you are not sure if your prototype got modified during transportation when you shipped through a UPS or DHL, or if it somehow got affected by vibrations during the plane, during the flight. So it's always good to do a last sanity check before they proceed to the testing. We already talked about most of those success stories here, but we do have a lot of IoT customers who need to have, or who have difficulties to ship prototypes, to ship devices to us, just because of the complexity of the device, or for confidentiality reasons. So we believe that P60 is the right kit to do the first antenna tuning on their own. Sometimes you are dealing with IoT devices that need to be in concrete, or on the drywall, or under the asphalt, inside metallic boxes, or directly worn by animals. So in that case, you can always do simulations, but there is nothing better than live measurements in the case of the real user case. We at PulseLARSEN, we do use those P60 devices for production also. So not only for debugging antenna tuning, but in our production line, we have mobile RF test platforms using the P60, so that the operators, the technicians on the line, once they build the products, as we do 100% sanity check after production, they use the P60 on a mobile platform to test all the antennas we produce. It's very compact again, and you will see very soon after the demo from Greg. And it will also help you to what people like about that kit. It's helping you to compare the performance of your real device compared to the demo board's performances, where when the antenna demo boards that we put in the kit, they are tuned in a certain way, and that gives you the best matching that you can have with those antennas. If somehow the antenna in your device is better or not, you can very easily compare and have a good idea of what you can get later on inside the device. Next, so Gregory will also talk quickly about how can you retune your antenna in your device. So some people are always asking us, what is the best recipe for the best antenna in the world? So obviously it's very hard, it's really difficult to answer that. But what we know is that P60 can help you see the impact of if you move the antenna around in your device. Sometimes there is a better location than the one you selected, and you can see that very fast. You can also verify that if you use inductors or capacitor values, what we call a matching circuit before the antenna, whenever you change the values of those components, you can see the impact on the antenna bandwidth and the antenna tuning. You can also see very quick that if you need to change the technology of the antenna you use in the device, you will see that very, very fast with the IoTest. You will see also the impact whenever you use chokes for isolating other elements inside the device. You will see the big impact of moving surroundings around the antenna. Again, if you move, as we talked about, battery, displays, cables, wires, other antennas, you will be able to very quickly see impact on your antenna tuning. You will be able to sometimes modify the PCB dimensions and the grounding around the antenna to verify if it helps your budget link or not. Next, you have a link here, PulseLARSENantennas.com/IoTest kit. You will find all information about the pricing, the data sheet you can download, pictures, and what it contains. And again, Gregory is going to do a demo to you. Very quick about Pulse. We are a 70-year-old company. We have 8 business units, 6,000 people worldwide, headquartered in San Diego. The antenna business units that I manage is located in Vancouver, Washington, where we also have a full operations, and as well as in China. We have R&D centers all over the world, and sales reps and DSTs and FAEs all around the world to help your design, to support your engineering teams all around the world. What we focus on as a antenna BU is transportation and IoT. We also do vehicular LMR type of business, infrastructure antennas, and small cell and DAS antennas. But for that purpose, we do a lot of transportation and IoT, smart home, smart metering, lighting antenna types. And the type of antennas we support, we do a lot of embedded antennas that are on the board. We do a lot of antennas cabled with microcoax cable, for example, and connectors to be inside the device, but deported with a cable. And then we do a lot of external outdoor antennas for different frequencies, different goals, and also combo antennas. We call them 5-in-1 or 6-in-1 that compose usually of 2 4G antennas, 2 or 3 Wi-Fi antennas, and 1 GPS GLONASS antennas. And then I will let Gregory take over for the live demo of that kit. Thank you very much for listening.
Thank you very much, Olivier. All right, so I'm going to share my screen real quick. That's going to look a little awkward at first. All right, and I'm going to start the IoTest software. Okay, well, this is the main screen of the IoTest software. Let me get my IoTest kit out of my work area real quick. First thing I'm going to do actually is take we mentioned earlier the black foam surrounding the analyzer. Hold them both out here. We'll explain why I put the black foam here in a second. Here's my analyzer. The little cap came right off there. Let's go to the caps there to protect the connector, of course. So here's my foam, here's my analyzer. This is the main sort of landing page for the IoTest software. So this is where it opens up every time you open up the program. There are sort of 3 main categories here that you'll select from: the learn, the measure, and the optimize. And I want to give a brief explanation for what each one entails. The learn section does a couple of things for you. The first thing it does is it gives you a list of all of the antennas that are in the kit. It also it gives you data sheets to go along with those antennas, gives you the information about them, their applications, the frequencies that they operate at, that kind of thing. The second thing it lets you do is when you have finally from that list decided which of those antennas will best serve your purpose, you can check your test environment, as it were, by testing the evaluation board using the analyzer and seeing if it does in fact perform where it should perform based on a saved memory trace inside the software. I'll show you how that looks. So you'll be able to see that your test environment's good, that you don't have other things in the way reflecting or something. The second section is the measure section, and you'll use that one essentially when you're ready to measure the antenna on your device board. You get your board out, it will give you much quicker response, as it were, to changes you're making to your board. The learn section holds your hand more, it takes more time to get through. The measure section gives you quick responses for the return loss measurements. So that's where you're going to go once you have an antenna on a board and you want to test it and see how to make sure it's performing at the right frequency, see if you need to tune it at all. That's where you'll go. Lastly, the optimize tab is really for when you've tuned the antenna yourself and you're ready to have it tested in an anechoic chamber, or if you just need a little bit of help tuning, maybe you've got some plastic housing that's giving you trouble or something else, causing some tuning issues, the optimize section will get you in contact with us and we'll be able to help you out. For your first time opening the program, it's always recommended before you do anything else, you hit the Get Started button when you first open up the IoTest software for the first time. What this welcome section will do is what the Get Started takes you to, is it lets you learn a little bit about the IoTest kit. I'll go through it briefly. It's really for when you actually have the kit in your hands. First, we have just an introduction section for what the kit offers. Next, a registration button. You see I am able to move left and right through my sections real easily, which is a great part of the GUI. It's really simple to use. This registration page is very important. I'm going to show you a bit more of it later when I talk about optimize and why you need to register. For now, I'll move on to the next part. Explains briefly why antenna performance is important, why you need to do these measurements to make sure that the signal you're sending from your radio is radiating from your antenna instead of just being bounced back towards your radio. In lieu of that, it talks about return loss in the next part, what return loss is, how you measure it, because it's important to have an idea of what you're actually measuring when you're using this analyzer. Finally, it gives you a brief explanation of the antenna analyzer itself, made by Copper Mountain Technologies, who we're working with on this IoTest kit. They make fine analyzers here, and we use them ourselves, as Olivier mentioned, in our own labs. So that's basically the welcome section. It's just a good place to go in your first use of the software to get an idea of what you're using. At the top of the screen, we see the same three sections we saw before: learn, measure, and optimize, along with a couple of other ones. So this is just another way this software is super easy to use. You can go through each section of the software easily with these left and right options, and then when you want to switch sections of the software, you can easily go up here and click the one you want. I'm going to click on Learn now. So this is the Learn section. Now, I mentioned briefly that basically what it does is, firstly, it lets you learn about all of the antennas in the kit. You can see they're all listed here. If I have interest in a particular antenna, please excuse me, I can click on this little I information button next to the antenna, its name, and it will tell me more, the features of the antenna, what applications it's used for, frequency bands of its use, things like that. So this gives you all the information about the antenna. It also gives me an option to access a data sheet for the antenna. The data sheet is installed in your computer with the software. You don't have to use the internet for this at all, and it's very helpful to have this data sheet to give you more exact specifications for the antenna, dimensions and things like that, what kind of performance you should expect to see. Also, the more info option will allow you to choose a location to save a couple things. One thing is the data sheet again. Also, it includes a 2D drawing of the antenna and a 3-dimensional file for the antenna. A step file you can import into something like SolidWorks to then see if it fits on your board model. So that's a request we have a lot, to get a 3D file for the antenna so they can see if it fits in their housing and things like that. So it's really helpful if that's included, saved in on your hard drive with the software for easy use later. A couple more things I'll show you here when it comes to determining what antenna you want to use. There's some search options. You can decide how many bands you're looking for here and limit the number of antennas you see to sort of make it easier to sort through. Or you can search, say I want a 2.4 gigahertz antenna. I type in 2.4 gigahertz and I get some options from the rest. Or say I want a GPS antenna, I can search for that application. And I get the GPS options that are included in the kit. For now, I'm going to, in fact, go forward and decide for my application, let's say I wanted a GPS antenna and I liked the W3010 when I read about its characteristics. So I've got the W3010, I hit select. And here comes the second part of the learn section, testing or determining your testing environment, making sure you can test your antenna, say on your test bench, in your lab, wherever you are. So first, this learn section is going to sort of lead us through using the analyzer step by step. You'll see in the top left corner here, hopefully, it says analyzer not ready as a red box. We're going to change that. It's going to tell us first to connect my USB cable to my analyzer. I'll select next, and it will tell me to connect my USB cable to my computer. Can't quite see that, but it's a simple USB cable. Computer is recognizing it. I'll hit next, and now it's telling me to connect my RF cable at the end of the analyzer here. I'm turning the nut. Always better to do that than risk damaging the threads. There. You'll also note that now this analyzer not ready turned into an analyzer ready, and it's green in the corner. It takes maybe 5 seconds for the analyzer to become ready once you plug it into the computer. It's very quick. There's also a green light on the analyzer itself. Now I'm going to go forward, and I have to calibrate. As mentioned before, calibration is critical when you're doing RF measurements. Essentially what the calibration is doing is it's telling the analyzer where the end of the 50 ohm transmission line is that we know is 50 ohms, and where the beginning of my antenna is, where I want to actually measure return loss, determine whether whether the impedance mismatch is there. So I hit next because it gave me a brief explanation of calibrating. And now it's telling me to connect the open of my analyzer to the RF cable. I've just done that sort of out of habit. RF engineers do it so often they get used to just doing it without even thinking. I hit next. Now I'm going to unscrew from the open and connect my short. Open, short, load is just very much the convention for the order in which we do this. So that's how the software is set up. Now I will connect my load. And push the next button. If at any time I made a mistake, if I had accidentally clicked twice and gone through one of my calibration steps, you can always go backwards and recalibrate. You can hit the red X to start over if you've made some kind of mistake. Super simple to use. I'm going to hit the big green check mark. I've calibrated correctly. Now on the screen, you'll see a couple things. First, you'll see these red sections and then this white section. The red sections are out of band. It's where I don't care about the frequency response. The white section is in band. I care about the frequency response there. Now, as I remove the load, you should see that black line moving across the screen. That black line is the current measurement at the end of our cable. So that's where we're going to connect our antenna and see how it's performing. You'll see lastly this dark gray curve here. This is a memory trace, provided with the program that tells you what the evaluation board, the W3010K that comes in the kit, should look like in a correct testing environment. So I'm going to connect my W3010K. I'm using this foam here. As mentioned before, we're going to talk about why we have it. This foam lifts my antenna a little farther from my surface here, in this case, this wooden table. It's important to keep your antenna away from things that might cause reflection, might detune the antenna. Antennas are very sensitive when they're performing correctly. So that's why the foam is included to help make your test environment better and more suited for the antenna. And what this is doing is letting me check if I see the response that matches the memory trace. I know I can do my testing on my test bench here, in my lab, wherever I am testing this antenna, wherever I happen to be at this point in time. Right now, you can see I'm here on this wooden table. I can see if I pull my hand away. Wow. So I'm seeing a very good response, very much pretty close to matching the memory trace. You can see it almost follows that line exactly. That tells me that this is a pretty good test environment. I could do testing of my GPS IoT device in this location, wherever this location is, whether it's my own lab and, or whether it's just on my bench next to my workstation in the office. So that's what this sort of learn section does. It tells me, okay, I'm in a fine place for measuring this antenna. I can do so on my own device in the future. So on the left, it was telling me about connecting the sample antenna using the foam jig here, using the SMA connector, how to tighten it. I'm going to hit next. It then tells me a little bit about characteristics of good antenna response, how it needs to match this gray shaded area, how the red areas are out of band, white areas in band. This is the band we sort of care about, the GPS band. This antenna, in fact, right now you can see it's resonating at negative 37 dB, which is extremely good. You know, 10 dB was where we were looking to get 90% power transmitted to the antenna. This is far even better, 99% of power is being transmitted. This antenna doesn't just resonate at GPS. There are a couple other global navigation system frequency functions in this band, such as, say, GLONASS, if you're using a GLONASS application. So this antenna actually is wide enough that it's better than 10 dB at all of those bands of interest. So it's great for no matter what global navigation system you're using. I'm going to hit next. Now it gives me some troubleshooting ideas if I'm seeing some kind of issue, you know, maybe you've made a mistake in the connection somewhere. And lastly, some options for getting support if you're having further questions. There's also an advanced settings option down here. I'm going to talk about that a little bit more after I discuss the measure section. So that's basically the learn section. What I've done is I've chosen a GPS antenna based on my application. In this case, say I need a GPS antenna for some sort of wearable device or something, who knows. I've taken that kit and I've measured it here where I would like to do my device measurements and decided, yeah, this is an okay place to do my device measurements. There isn't, say, metal or something nearby that's making the measurement incorrect. So I know I can do these measurements here. Now I want to move on to the measure section. Now it did a little bit of loading there. It won't actually be able to load the screen if your analyzer is not connected. It is connected. I'm going to leave my antenna here for now. On the left here, tell us about your antenna. You choose the antenna you're using. Again, I'll choose the 3010. And it loads the same thing we saw before in the learn section, but much quicker. You know, there's much less hand holding in this case. It assumes you've already used the software and know what you're doing. Now I should calibrate the antenna if I've just loaded the measure section because I've just perhaps done this measurement for the first time today, as it were. I'm going to skip that for now in the interest of time, and we'll calibrate again soon with a different antenna. But you can see again the response is very similar to what was before, less than 10 dB or better response than 10 dB across our entire white area shaded band of interest. Move forward, it says connect the test setup. But again, this is brief explanation like the learn section, but much briefer for how to set up everything to your measurements. It tells me to calibrate my antenna analyzer. This is blinking, and on the left here we see it's red and uncalibrated. I'm going to skip that for now, but you should do that every time you're doing your first measurement of the day pretty much. It tells me to connect my antenna. I've done so. It tells me to consider the antenna's performance and gives me options for getting support. Now, I mentioned I wanted to talk about the advanced settings when I was looking at measurements. Here you can see a few options to change what's being shown on the GUI here. The resonance tracking marker, if I deselect that, that's the point where it shows you the maximum resonance. That's useful to keep on there. One thing was mentioned in the presentation about whether or not you can tell if your antenna is sensitive or not. If I bring my hand over the GPS, we can see how it's immediately been affected by that. Now that resonance point is at too high a frequency, so I'm pushed out of band by the fact that my hand's nearby. That's just one of the things I can detune an antenna. And you'll note it actually, the software recognizes that I'm out of band and I need to do tuning. Even though it's a very good resonance at negative 20 plus decibels, it's in the wrong location. So the software recognizes that that's not where I want my resonance to be. With my hand in the way, at part of that GPS frequency, you can see I'm actually less than 10 decibels, which is where I'm interested. So that's the resonance tracking marker. And also you can put on markers, which are at the band edges themselves, and labels for those to determine exactly what the return loss is at the band edges. So we see less than 10 decibels at both edges of the band. Very good. You might note when I moved the antenna trace here, you didn't see that shaded constant area of the memory trace from before. You can add that back if you want to by selecting memory trace. There we can see the memory trace there as it was before. If we want to, we can also remove the red out of band shading. You might have some reason to do that, but it's very helpful to see it there. There's one final options in the advanced settings, which is the show antenna analyzer. I'll show you that a little bit later. For now, I'm going to save it until after the optimize section. I also can change the number of sweep points if I want to. You don't have a particular reason to do that usually. It doesn't detract or add too much to your measurement. So generally you leave it alone, and if you change it, it will confuse the memory trace that's saved into the system, so you won't be able to use it as effectively. Now that's a large part of the measure section and what its uses are. I want to show a bit more use case for, this is just the evaluation board, which you probably aren't going to use in the measure section. You really want to use your device in the measure when you're using measure here. So first thing I'm going to do is test a device that uses a W3108, which is a 2.4 gigahertz. So I'm going to go back to tell us about your antenna and choose the W3108. Now I've got tape covering this device because it's a customer device, so I can't show off the intellectual property of theirs. Oops. Getting ahead of myself. So I've done that. If I go through my steps, it's going to tell me to connect test setup. I've done that, and to calibrate. Now it is important that I calibrate because I have changed the frequency that I'm testing at. Before I was testing at GPS frequency, which is 1575 megahertz. Now I'm testing at Wi-Fi at 2.4 gigahertz. So it's time to calibrate again. It's the same process as before, a little bit simplified on the screen. You see now it just tells me to connect open, short, and load. Again, it assumes I've already used the learn section or know enough to understand what I'm doing. And the learn section will help you learn more about why you're calibrating. Connecting my short. And connecting my load. Next, and the green apply. Oops. Go to advanced settings. Because I'm using my own device, I certainly don't want the memory trace. I'm just going to leave the resonance tracking marker on again. The memory trace will be confusing because you shouldn't expect once the antenna is in your device to match the evaluation board exactly. What you should look for is a nice resonance within your band of interest. So I'm going to connect a cable, and I'll show you a bit more about how to get a cable on your board later. This is essentially how you make sure you can actually measure using the analyzer the return loss. So you hopefully can see within the 2.4 gigahertz band a very good resonance at 2.43 gigahertz, just left of middle, all the way at 40 decibels. Again, that's far more than 99% of power is being transmitted. So this is a device that's been tuned a little bit because of the plastic housing it's in. And of course, the tape has some effect as well on the tuning, which wouldn't be in the effect in their real use. But so that's sort of one use of it. This is what you want to use your measure section for, to measure the device on your board. You can make changes to your board as it is, the board size. In some ways, you might need to change an inductor or a capacitor that is on the feed trace to the antenna in order to tune it. Tuning is a sort of complicated sometimes process. There's a lot of different options for tuning. We'll talk a little bit more about that in the optimizing section. One more device I want to show you. It's designed for 915 megahertz. It's an ISN application. Again, there's a bit of tape over it to hide the inside. Can't show the board off. So I'm going to tell us about my antenna again. This one happens to be the W3113, the 915 megahertz, which is located right here. And the reason I'm selecting this one is I want to show how important it is to keep your test environment in mind. Once again, I'm going to calibrate because I've selected a different frequency range. If you're an RF engineer who's done multiple tests in a day, you know how eventually you might get a little tired of calibrating, but it's critical every time if you change what your analyzer is looking at to calibrate it so it knows exactly where to consider the start of the antenna, as it were, where to be measuring that impedance mismatch. So it takes a little bit of time, but as they say, measure twice and cut once. Very important to make sure that your measurements are accurate. Good. Now I'm ready to measure my device. Now, as I've connected it, I'll even leave it here on the phone. you might note that it says it's out of band, that tuning is needed. And in fact, the resonance is appearing at 945 megahertz. That's because this device is not designed in order to radiate just in free space like this. It's designed to work in a particular material. Now, I can't show you what that particular material is, but I can show you the effect. What happens when I actually put my device where it should be. I have to lift the analyzer a little bit, unfortunately, because it's a tall container. But as I put my device in this material, you'll see that resonance shifting back down to in band. Now it's resonating at 910 megahertz, 25 decibels. It's excellent. Very good resonance point there. So that's an explanation, a visualization of why you have to consider your final use environment when you do these tests. If I go all the way down to advanced settings, choose to add markers and marker labels, I see I've got 17.5 dB return loss at 902, 9.5 at 928. That's almost 90% power that is being transmitted past the reflection point to the antenna, about 10% reflected back to the radio. So that's pretty good. That covers the entire band. That's quite good. That's what you'd want to see moving forward with once you finish tuning. This is what you'd want to tune the antenna to, pretty much. So it matters when you do this measurement section that you take in mind your final test environment. That's why we can see immediately the response when we take the antenna out of the material it's in. It's very important to keep it in mind. The last thing I mentioned I wanted to show was this antenna analyzer option. If I select it, I only want to select it if I'm a more experienced network analyzer user, because what this does is it actually opens up the software that is the full network analyzer. This comes with the IoTest software. It's what the IoTest uses to show you that nice, beautiful, simple return loss screen. But if you are more experienced, you can open this up. You can use it to view, instead of log magnitude form, SWR. You can use it to look at a Smith chart if you're comfortable using Smith charts to change tuning, perhaps. So this has all the full capabilities of a network analyzer. You can change all sorts of things, add markers where you want. You can calibrate here, load and save state files here. You can export data here. You can do everything you would expect to do with a network analyzer in this software. If you've opened it up and decided you're done using it, instead of hitting the exit button, which will confuse the IoTest software since, again, it is working in tandem with this Fuller software, I'm just going to go back to it and unclick Show Antenna Analyzer, and it disappears from here. So that software is there for the advanced RF user who likes the idea of a nice portable analyzer like this one. They don't need to use only this return loss screen here. They can do a couple extra things using that software. Smith chart can be very valuable for somebody who knows how to use one when it comes to tuning. But if you just use the return loss, you can get a very good idea of how well your antenna is going to operate, how well it's radiating. You can check, again, sensitivity. You can see this one's not very sensitive to my hand due to the housing it's in and due to the frequency. You can determine a lot of things about the antenna based on that return loss plot that will help you moving forward, determining when you're ready to do chamber measurements or go for certification.
Greg, sorry to interrupt, but can you move the container out of the way?
Oh, okay, sure, sorry. Whoops. Okay, put my antenna back here. So I'm going to move on to the optimized section now, the third section I talked about at the beginning. This is a brief discussion section because what the optimized section does is explains to you what PulseLARSEN can offer once you've got your antenna tuned as far as you care to go because it's performing excellently, or as far as you've been able to do yourself before you decided, I just need a little bit of help. I don't really understand how to use these inductors and capacitors on the trace. I don't understand why when I put copper tape on the side here, I get better resonance. If you need a bit more help, or if you are looking to get anechoic chamber results, this is where you can go to talk to us. It explains our capabilities, whether that be passive measurements to give you an antenna efficiency, whether it be active tests like total radiated power and the isotropic sensitivity, so you can determine directly if you're meeting certification requirements before taking it to that third-party test lab. It also has the Register Now button, which I mentioned before. If you select this button, it will open up the page here with asking for your name, address, and company. It's very important you fill this out in order for us to help you. We will need to know where you're from, who you are, and how you have the software, how you've come across the software. This is the first step to us helping you out in the final tuning of your antenna or in the measurements of your antenna to give you that peace of mind that you are passing certification, that you are going to have a device out on the market in an even shorter period of time. So it's very simple, just name, email address, and company, complete registration, and that'll let us know. There are two more tabs I'll discuss briefly here. Resources tab, which gives you some more reports, presentations, as it were, with simple information about antennas, such as what gain and efficiency are. Some information about how ceramic chip antennas in particular work, how they're used and such, which are the majority of the embedded antennas. Here are either ceramic chips or they're helical style chips. Some other information, psychics of antennas. There's also a Q&A section with less lengthy reports and more quick answers to some questions you may have, such as how you're trying to determine what frequency range you need, what specifications are critical for an antenna. And one important section, I wasn't able to show you the cables connected to the antenna boards, unfortunately, due to the fact that these are customer boards. But this gives you a description or explanation with visualization of how to connect a cable onto your boards. You can take return loss measurements, taking a coaxial cable here, ending the trace by cutting the copper between the radio and your antenna. Just cut the copper there so that they're not actually conductive to each other. Then you get your inner conductor on a bit of copper at the trace towards the antenna as near as you can. The outer conductor soldered towards ground copper away from around the trace. So that's a sort of simple explanation for how to actually put a cable on your board so you can do the measurements. One more thing this kit includes, that's really important actually, because maybe you don't want to just use an embedded antenna. Maybe you have a couple other options you want to consider. This comes with some adapters, especially the middle one, the male to UFL adapter, the SMA to UFL. This can be extremely helpful if you are interested in using a flex antenna. It's a little hard to see there, but the picture there makes it better. We have a very popular, say, ISM antenna here. Maybe you're interested in this dual LTE plus a GPS antenna. It's a MIMO LTE with a GPS. You don't have to limit yourself to just the antennas that are included in the kit. You have options to test other antennas as well. Back in the measure section, instead of choosing one of these antennas from the drop-down menu, I click I have my own antenna, and I determine the frequency range that I'm interested in. Maybe I'm interested in that ISM band, so I type in 902 megahertz, 915 megahertz, or excuse me, 928 megahertz. Very popular band. Boom, I can take a look at that measurement range without having to have chosen one of the antennas from the kit. I can use this W3312, say, using this adapter on the end of this RF cable. You'll also need, in that case, this female-female adapter that is included as well. But so you have options besides just the kit options. This is a very versatile kit, including all sorts of things beyond just the embedded antennas. So we didn't want to limit anybody with choices in antennas. We wanted to make sure you're able to choose and test exactly what it was you determined was best for your application. I believe that basically concludes my demonstration of the software. We're going to see if we have any questions now, I think.
Yeah, I don't see any questions just yet. If you guys have any and you want to input them now, Olivier, do you want to go over the last couple slides really quickly? Olivier, do you want to do the last couple slides and then we can see if any questions come in?
Sorry, I was on mute. Yeah, can you pull up the slides?
I absolutely can.
Thank you.
Mm-hmm.
So we only have one more slide. So how can you get the kit and how much does it cost? So the kit, can you use Greg, please? Thank you. So the kit goes for the kit goes for $10,000, including all the demo boards, the antenna analyzer, calibration kit, etc. The whole set that you saw on during the demo. And we also made second pricing for $13.99, meaning that we provide 6 hours of engineering support in case you need some engineering support for the first design of your product. So basically, if you decide to approve the second pricing, my engineers anywhere in the world will help you as up to 6 hours to either verify the PCB layout, the antenna surroundings. We can build a prototype for you. We can make measurements in one of our chambers, provide you the report, all the way up to 6 hours of engineering support. So this deal is usually very well welcomed by companies that have their first experience with antenna design. They like to have a little bit of guidance, even though they buy the IoTest, and therefore make sure that they are in the best conditions to approach the market with their antenna tuning. And that's it. And then I will let it open for questions.
I didn't see any questions pop through while you were going through that slide, Olivier.
Okay, so then I can maybe we have done quite a few presentations in the past, and we have collected some questions that usually come up. So some people were asking us, what is the frequency range for the P60? It goes all the way from 1 meg to 6 gig. So which covers more or less all the frequency bands that you need for the IoT today. What is the frequency range covered by all the demo boards you have on the kit? So we have as low as 315 to all the way to 6 gig. So we have 2.4 only, we have 2.4 and 5 gig, we have 915, 868, we have some GPS tuned demo boards, 433, 315, etc. Some people are asking us if that kit needed additional power to run the P60 or to run the whole demo set, and no, there's only one USB cable that you plug from your computer to the P60, and that switches on the whole analyzer. We talked about the adapters, the connectors, the 3 types of connectors we add in the kit. So you are not limited to just SMA from the RF cable that's provided in the kit. We also had questions related to the software. Is there any other softwares that need to be downloaded somewhere after you buy the P60? No. The answer is no. You just plug the kit, and it will download automatically the software, and you will get everything in there, and you're ready to go within a minute. We also had questions about, can the P60 export data or save and recall calibration? So actually the P60, you will be extremely surprised. It's a very compact device, but it is a full-powered, full-functional reflectometer. So it has and it acts as a real vector network analyzer. And Greg showed you that you have just a simple switch between the GUI that we created on top of it and the software that runs behind. It is a VNA in its own, and you can either use the real VNA from the P60 itself, or use the additional software that we created on top of it to simplify the interface for users who are not VNA experts or VNA user experts. So that hopefully answers a few of your questions. If you have any more, you're welcome to ask now. If not, we will we will display our emails. You can reach me at orobin@pulseelectronics.com. And we also have website, PulseLARSENantennas.com. Whether you are located in Americas, Europe, or Asia, you have different emails for faster answer. And we have the 800 antenna number where you can reach Rita or Justin in Vancouver, Washington, that will be glad to answer your questions on the phone. So if you want to receive the recording, if you want to receive the presentation, if you need additional information, if you want to receive a quote, you can contact us freely and we will send that all to you.
Great. Okay, it doesn't look like any questions popped in, so we can go ahead and probably conclude the webinar. I wanted to say that if you did register for the webinar and put your information, you will receive a recording of this once it's processed by Big Marker. Thank you all for coming today to listen to this great content that Olivier and Gregory gave us. And thank you guys for taking the time to present to us.
Thank you so much. Have a good day or good night.
Yes, absolutely. Everyone, have a good rest of your day.
Bye-bye.
Thank you.